everyone. So we're back here now in the lab to look at biochemical oxygen demand, so BOD. So this is actually going to be the exact same procedure that we did last week for dissolved oxygen. The only difference is our samples have been incubated now for 5 days. So you may remember in the last lab when we took our sample bottle and we fixed it. So we added manganese sulfate and the Winkler's reagent to it. And then one of the samples we tested right away for dissolved oxygen, and the other I mentioned I was going to put it in the incubator for 5 days. So this is our sample after it has sat there at about 20 degrees Celsius for 5 days. So now we're going to test it again using the exact same procedure for the biochemical oxygen demand. So you're going to compare the values of oxygen content that you received in the first lab for dissolved oxygen to the results that we get in this lab for BOD, and that will allow you to look at the differences between the two and how they change after that 5-day incubation period. So the procedure is the same as I already mentioned. So we're going to start again with standardization of our sodium thiosulfate, and then we'll move on to our sample analysis. Okay, so let's start our standardization procedure for the sodium thiosulfate solution. So once again, we have our sodium thiosulfate in the burette here. Okay, so that's the same solution we used last week. We're just going to standardize it again to make sure that there hasn't been any change in concentration since last week. So there can be minor things like evaporation of a small amount of water, and even a small amount like that can affect the concentration. So we always want to make sure we standardize it again anytime we run more samples. So you may remember from last week, our sodium thiosulfate is in the burette. So we're going to add our reagents to our flask here. So we have 2 grams of potassium iodide again. Let's add that to our flask. Then we're going to dilute it in 150 milliliters of distilled water. Using a graduated cylinder. Swirl to dissolve. Now we're going to add 5 milliliters of sulfuric acid. So we're going to use an Eppendorf for that. 5 mils. There we go. And a few drops of our starch indicator. That should be enough. And then we add our potassium iodate solution. Remember, this is the one we diluted last week. So I'm going to use a volumetric pipette and add 10 milliliters of our potassium iodate solution to our flask. You see that bluish green color again? Go. And now we're ready to start our titration. I'll lift my burette a little bit. So we'll take our initial reading and then we'll start the titration. And we have a better idea this time about how much solution we have to add because we did this titration before, so we know about how much it takes, which is helpful. I mean, we can move things along a little bit faster. And remember, we're looking for a colorless endpoint. So as soon as that blue color is gone. And it may be a little hard to see this on camera, but as we get close to the end point, there's still a faint bluish color there. So I'm looking down through it on the white paper, and I can see there's a little hint of blue. So I'm just going to add one drop at a time until the blue color is completely gone. And we have a completely clear and colorless solution. Going to spray down the insides again to get all of this titrant in the actual flask. There we go. So the blue color is completely discharged. We're left with a colorless solution. So as in the last lab, we're going to do 3 of these titrations, and again, you will be provided with the results. So that's the standardization. Our next step is the analysis of the samples. Okay, so this is our sample, and again, that's a surface sample from Kent's Pond, so the same sample we used last week. So this has had the reagent A and B added to it, it's been incubated, and now it's been allowed to settle. So now we're going to do the next step in our sample analysis, which is adding 1 milliliter of sulfuric acid, so we're acidifying the sample. So that's reagent E, our sulfuric acid, 50% sulfuric acid. So we're going to add 1 milliliter. Stopper again. Okay, and now we are going to shake that. And we should see, like we saw last week, that the precipitate dissolves and we're left with a yellowish solution. Okay, so you can see now that our precipitate has all dissolved. We're left with a yellowish orange solution. So now we're going to take a 50 ml aliquot of that and put it in a Erlenmeyer flask for the titration. Okay, so now we're ready to start our titration. So, remember, we did this previously. We're going to titrate until we have just a faint yellow color, and then we'll add the starch indicator at that point. So we've got a fairly deep yellow now. We want to get just a faint, just a trace of the yellow color. There we go, that's pretty good. Now we're going to add our starch indicator again. We want to add enough to get a deep blue color. Should be good. And now we titrate, or continue our titration. So we don't take a reading until we get to the end. So we continue our titration until this solution goes colorless, and it generally does not take very much. There. So we have a clear, colorless solution. So that is our endpoint. So again, as I mentioned, we'll send you the results for this part of the lab for the biochemical oxygen demand. And you can compare your results to the results you got when we did the dissolved oxygen content immediately after we took the samples. So the results will be forwarded to you for both parts. Thanks for watching. I'll see you in the next lab.